Geeks for Geeks question for 9th May, largest number in K swaps. So we are given two things. First is a number that is represented as a string, and another is an argument K. So what they're asking is that we have to convert this number into as large number as possible by performing at most K number of swaps. So here we can swap 1 and 7, then 2 and 6, and then 3 and 5 to make this. And we only perform 3 swaps, but it is no longer possible to make this number any more larger. So we can make less swaps, but we cannot make more swaps than 4, right? So we have to return this string. The approach we're going to use is greedy approach. We're going to traverse each element until the value of K is greater than 0. If the swapping is beneficial, means that it is possible to swap. I mean, there is a number for, let's see, for 1. If there is a number that is greater than 1 after 1, then it is possible to swap. It is beneficial to swap. Then we are going to swap it. Otherwise, we are going to move to the next element. So the complexity of this approach is going to be n square. How? We're going to traverse each element once, and for each element, we're also going to traverse all the rest of the array in order to find the next best element to swap with. Now this complexity looks big, but here the constraint are only 15. So the size is 15. So max complexity would be 15 raised to 15, which is also 2 less, right? And this is considered as an optimal approach. The space complexity is obviously 1. So this is another example, simple one. This is a edge case example. So here we are given this number and K is equals to 3. So for 4, what we are going to do, we are going to find the largest number after 4, that is 7. Is 7 greater than 4? Then swapping would be beneficial. But the thing to consider here is to not this 7 with 4. We have to swap this last 7 with 4 in order to make the number as large as possible. So we have to find the largest number after 4 and also make sure that it is the furthest one, the last one. Okay, so let's code this first. We're going to traverse for every element. Then we will keep then we will track what is the next element that is greater. If there is an element that is greater after this, we're going to swap it with this. So index is -1, and another loop. It starts from the next element, starts searching from the next element. So if s of j is greater than the current element that is currently maxi and stored in maxi, so we are going to update maximum, and also we're going to update our index. Then once this loop is over, if the index is not -1, which means we did found a beneficial swap that is possible, then we're going to swap them s of I and the one that is stored at index, and also reduce k here, right? And here we are checking if k is 0, you simply break the loop, and in the end we are going to return the s. Now there is one problem in this code. We are only checking for greater. So s of j is greater than maximum, right? So suppose here for this edge case, we encountered this 4, right? We are searching for 4. So we started searching for 5. Now the maximum is 5. Here, when our pointer reaches here of j, the maximum becomes 7. Now when we reach the last element, the s of j is 7, but it is not greater than maximum, right? It is greater than or equal to maximum. But if we do that equal to condition, we face another problem, that is here. So 5, it is also greater than equals to 5, right? So what it is going to do, it is considered that we should swap this, but we should not, because these are all same elements. So we have to write another condition actually, rather than doing greater than equals to. So, or we can write s of j is equals to maximum, that is fine, but we have to make sure that we are not actually comparing it with the same. So s of j should not be equals to s of I, or we can also say that the index should not be -1, right? So that means that we have at least found one element that is greater than s of I. That then only index would be not -1, right? So this will work, and let's try submitting this. All right, it is passing all the test cases. You will get this code in the on GitHub, in link in the description. All right, thank you.